This Kefa in chapter 3, I'm going to be doing exercise 3.7, and the question there, we are given the coordinates of a bird flying in the x and y plane, which are given as the x coordinate to be x as a function of t to be alpha t, and the y coordinate to be 3 minus beta t squared. So we are asked the first question, we are asked to calculate the velocity of the bird as a function of time. The velocity of the bird as a function of time. So we know this is x of t is equal to alpha t. That's the position of the bird in the x component, and this is the position of the bird in the y component on the y of t. So therefore, to find the function of velocity, what we have to do is to take the derivative of these functions, that's to differentiate. Therefore, the derivative of this x, first the derivative of x as a function of t is going to be just alpha, and the derivative of y as a function of t is going to be the derivative of 3. 3 is just a number, so a derivative of a number is 0, and the derivative of the other part is going to be negative 2t. So we have two derivatives in the y and the x component. So the question asks, we ask you to find the velocity vector of the bird at this point. So what we need to do, we just have now to substitute the value for beta and the value for alpha in these two equations, this and this one. So what we do, we have beta equal to, alpha equal to 2.4. Therefore, this is going to be 2.4, and this one is going to be negative 2.4 t, because is negative 2.4 t. So in the coordinate form, we are going to have it as, it's going to be 2.4 comma minus 2.4 t, and of course this is meters per second. Okay, part P is going to be, the part P, we are asked to find the acceleration vector of the bird. So what we do, take the second derivative from the first one. So second derivative of x is, so a function of t is going to be 0, and the second derivative of y is going to be second derivative is going to be negative 2 beta, and this is going to be in terms of the coordinate. If we substitute in, we put the numbers beta, this is going to be negative 2.4, because it's 2 times 1.2, bringing us negative 2.4. So in coordinate form, we're going to have it as 0 and negative 2.4 this way, which is going to be meters per second square, because it's acceleration. So part C, we are asked to find the velocity of the bird at t is equal to 2. So part C, at t, velocity at t is equal to 2. So we already know the velocity function. We're going to have it as velocity function we already know is equal to 2.4 comma negative 2.4t. So whatever we have t, we substitute 2. In this case, we only have t in the y component. So what we're gonna have is gonna end up to be 2.4 comma negative 2.4 times 2, which is going to be 2.4 comma 2.4 and the negative 4.8. So this is going to be 2.4 negative 4.8, and of course this is meters per second. Okay, we finding the magnitude. So to find the magnitude of V is going to be the root of 2.4 squared plus negative 4.8 squared. If you compute that one, it's gonna give you let me calculate. It's gonna give you 5.4 meters per second. So to find D, I'm not part D, but the D is asking we need to find, but the D we need to find the direction of the body's velocity at t is equal to that one. So the direction, we already know the y component and x component in terms of velocity to be 2.4 and negative 4.8. Therefore, it's easy to do that. So theta later is going to be arctan negative 4.8 or over 2.4, which is gonna give us 63.4 degrees. So the real angle, so if you draw that vector, I think it's lying in the fourth quadrant because the y-axis is negative and the x-axis is positive, so that vector is somewhere around here. If that is 63.4, therefore our angle will be our reference angle, which is 360 degrees minus 63.4 degrees, which gives us 296.6 degrees. So that's part D. So that's direction in terms of velocity. So to do part C, I'm going to do part E. Part E is going to be, we are asked to calculate the magnitude of the body's acceleration. We already know the component of x and y in terms of acceleration, which is this one, 0 and negative 2.4. So to find the magnitude of A is going to be just 0 squared plus negative 2.4 squared and the root, and this is gonna give you 2.4 meters per second square. So that's E. And F, we are asked to find the direction of the body's acceleration at t is equal to 2. So the direction is gonna be given as theta is going to be arctan negative 2.4 divided by 0. And of course, if you put this in the calculator, it doesn't come. I think it's best if we can present that on a sketch here. So because we have the coordinate to be 0 and the negative 2.4, if I put it on the sketch here to find that vector, I think my x is 0 here. Let's assume this point here is negative 2.4. Therefore, that ends here. This vector comes all the way here to this point. So the angle here is going to be from here all the way here. And you already know at the exact y-axis, this is 270 degrees. Therefore, the angle there is 270 degrees. So G, they say, is the body speeding up, slowing down, or moving at a constant speed at t is equals to 2 seconds. When the body is moving at constant speed, it means the components of acceleration must be 0, 0. So, which is not the case here because we have 0 on this. So, we disqualify that one. It's not going at constant speed. If we say slowing down, we must have the component of either component of the velocity or the acceleration to have opposite signs. So in this case, we have negative 2.4 for the acceleration here, and we have negative 2.4, negative 4.8, and we have negative 4.8 for the velocity. That means it's not slowing down. Therefore, the best answer will be, that's by G is gonna be speeding up. Reason being, velocity function and the acceleration function, they have same signs, same signs. Therefore it's speeding up. So I'll take choice A, speeding up. And that's the end of this. Thank you for watching.